Hello everyone, welcome to the lecture on Mechanics of Solids Introduction. These are the contents. First one is introduction, second one is the syllabus, third one is course outcome. Let us look at the introduction part. What is mechanics? So as you already know, the mechanics of solids is basically mechanics subject. In the first year of your BTech, you have already learned engineering mechanics. So already you should be knowing what is mechanics. Mechanics is a branch of physics which deals with the study of effect of forces on the bodies which are either at rest or in motion. So as you can see the definition, we can understand that in mechanics we are mainly studying effect of the forces. On what? On the bodies, which may be either at rest or which may be in motion. So if you see here, bodies may be at rest or they may be in motion. When they are in these two states, forces will be acting on those bodies. So these external forces will bring some changes in these bodies. So what these changes? So that we are going to study in this mechanics. So this is mechanics. So this is the basic idea of mechanics. So this is very essential to understand what is mechanics, to understand the complete subject of mechanics of solids. Because if you see the name of this subject, it is having mechanics of the solids. So here we are studying the mechanics of the solids. The solids you already know, but what is this mechanics? So this is mechanics. So mechanics is the study of effect of the forces on the body, which may be at rest or in motion. So this is mechanics. So if you see here in this definition, there are two things. One is body at rest and body in motion. So already in the engineering mechanics, we have already learned that when the body is at rest, and if you study the effect of the forces on that body, then it is called as statics. And if the body is in motion, and if you study the effect of forces on that body, then it is called as kinetics. So like this, we can classify the mechanics. But is this the only classification of mechanics? No. We have other classifications of mechanics as well. Okay. So let us see what is the main classification of mechanics. Okay. So classification of mechanics. If you see this flow chart, we'll come to know that engineering mechanics is divided into two categories. First one is mechanics of solids and second one is mechanics of fluids. So this is mechanics of solids and this is mechanics of fluid. How this classification has been done? But it is based upon the types of bodies. So as we know, bodies may be either they may be solids or they may be fluids. Okay, so if you are studying the effect of forces on the solid bodies, then it is called as mechanics of solids. And if you are studying the effect of forces on the fluids, then it is called as mechanics of fluids, or you can say fluid mechanics. Okay, so in the present semester, we are concentrating on this mechanics of solids. And in the next semester, we will be learning this fluid mechanics as a subject. Okay, but if you see here, mechanics of solids. Solids, again, they may be classified into two types. One is rigid bodies and another one is deformable bodies. Okay, so what is the difference between this rigid body and the deformable body? Okay, so because you should already be knowing about these rigid bodies. Why? Because you have already learned engineering mechanics, and in the engineering mechanics subject, we have only studied the mechanics of rigid bodies. Okay, so that's why we should already be knowing about the rigid body. Okay, but this deformable body is a new concept for you. Okay, so but let's see what is the difference between the rigid body and the deformable body. Rigid body is a body whose dimensions do not change considerably whenever the external forces are acting on the body. So this is called a rigid body. So because as you already know, whenever there is a force acting on a body, there will be changes in the dimensions of the body. But if the dimensions of the body, changes in the dimensions of the body are completely negligible whenever the external forces are acting, then that type of body is called a rigid body. Okay, but if the external forces are acting and the changes in the dimensions are considerable, that means we can easily identify the changes in the dimensions, or you can say size in the change in the size, then that type of bodies are called as deformable bodies. So this is the major difference between the rigid bodies and the deformable bodies. But in the universe, all bodies are deformable bodies. There is no such body which cannot deform under the action of the force. So hence we can say that rigid bodies are completely hypothetical. They are imaginary. They do not exist. We are imagining that the bodies will not change in the size when there is an external force is acting on the body, and we imagine that and we proceed. So that is called a rigid body. Again, this mechanics of rigid body can also be classified. Not only this mechanics of rigid body, the mechanics of all these bodies, mechanics of fluids, mechanics of deformable bodies, and mechanics of rigid bodies can also be classified into two types. One is statics and another one is dynamics. Okay. In the definition of the mechanics, we have already came to know that bodies may be either at rest or they may be at motion. Okay, so based upon that condition, we are going to classify the mechanics as statics and dynamics. So what is statics? When the body is under rest and if we study the effect of forces on the body, then we can say that it is statics. And if the body is under motion, then it is said to be dynamics. Again, this dynamics is classified as kinematics and kinetics. So kinematics and kinetics. So what is the basis of the classification of dynamics? It is based upon the motion as well as the causes of motion. Because whenever we say a body is in motion, there should be some cause for that motion. Whenever there is a force acting, then only motion will be there in a body. So therefore, whenever there is a motion, there will be causes of that motion as well as motion geometries. So if you consider both of them, it is called as kinematics. Okay, so if you don't consider the causes of motion and if you consider only the motion geometries, then it is called as kinetics. Okay, so that means we are considering the motion as well as causes of motion, and if we are considering only the motion. So based upon that, this can be the dynamics can be classified into two types. That one is kinematics and another one is kinetics. Okay. Next, coming to the deformable bodies, the mechanics of deformable bodies, it can be classified into three types. One is strength of material, one is theory of elasticity, and another one is theory of plasticity. So here, strength of material. So this is the first one, the strength of material. So this is what we are going to study in the present subject. So this is the area of our study. Okay, so these two, theory of elasticity and theory of plasticity, we will be studying at the higher levels. Okay, so now we are not bothered about this. We are only bothered about this. Okay, so this we are going to study in the present subject. Okay, next classification of engineering mechanics is mechanics of fluids. That is fluid mechanics. Again, fluids can be classified into ideal fluid, viscous fluid, incompressible fluid. So based upon that, we have different types of study areas. But basically, it is mechanics of fluids, or it is a fluid mechanics. That is FM. So this we are going to study in the second semester of second year, and this we are going to study in the strength of metal, that is nothing but mechanics of solids, that we are going to study in the first semester of second year. Okay, so this is regarding the classification of mechanics. Now, after understanding what is mechanics and what is the classification of mechanics, now we should know what is mechanics of solids. Okay, so we have already learned this mechanics of solids in classification of engineering mechanics here. If you see here, deformable bodies. So mechanics of solids, deformable bodies, and strength of metal. So that we are going to study in the present subject. So that we are going to see. So here, this mechanics of solid deals with how solid bodies will react when they are subjected to external loads. Okay, so here solid bodies that to deformable bodies. So the deformable bodies we have already defined them. That means whenever the external load is acting on the body, there will be considerable change in the dimensions of the body. So then it is called as the deformable body. Okay, all solid bodies they are deformable. So therefore, this mechanics of solids mainly concentrates the mechanics in this mechanics of solids. What we are going to do is we are going to study the effect of the external loads on these solid bodies. Okay, and there are different types of loads acting on this body. Whenever these types of loads are acting on this body, like this here, like the one which is shown in these kind of figures. Okay, whenever there are different types of external loads are acting in the body, there will be changes in the size, there will be changes in the shape, and there will be internal resistance offered to the external load. Okay, so all these things we are going to study in this mechanics of solids. So based on this, we are going to determine the strength of a particular body. So that we are going to do in this mechanics of solids subject. So this is the main idea of this mechanics of solids. You should know why we have to learn mechanics of solids subject. So this is the reason for studying this mechanics of solids subject. Okay, so this will help in designing of various types of bodies which are under various types of loads. Next, we will have a look at the syllabus of this subject. As usual, it is having 5 units. In the first unit of this mechanics of solids, we are studying simple stresses and strains. Unit 1 is simple stress and strains. Okay, so here this is basic for this subject. We should know these things completely. We should understand them thoroughly. Then only it is easy to understand remaining units. So this is the basic concept, simple stresses and strains. So these are the basic concepts. Whatever we are learning in the unit 1, they are completely basic concepts. You should understand them thoroughly. If you understand those things thoroughly, then the remaining units will become easy to understand. Okay, unit 1 is simple stresses and strains. Coming to the second unit, it is shear force and bending moment. So here we are going to draw some diagrams. They are called as shear force diagram and bending moment diagrams. Okay, and here we will be having the concept of beams, types of beams, and types of loads. Okay, so whenever these types of loads are acting on different types of beams, then we should know what is the variation of this shear force and what is the variation of the bending moment. So that we are going to represent graphically. So they are called shear force diagrams and bending moment diagrams. Okay, we'll study them in deep whenever we start our lecture series. Okay. Next, coming to the unit 3, we have 2 parts in unit 3. First one is flexural stresses. They are also called bending stresses. That means whenever a body is subjected to bending, the stresses to be developed, those types of stresses called as bending stresses are also They can be called as flexural stresses. And the second part of this unit 3 is shear stresses. Okay, so these two things we are learning in unit 3. Okay. Next, coming to unit 4, we have two parts again in unit 4. First one is principal stresses and strains, and second one is theories of failures. Okay. First one is principal stresses and strains, and second one is theories of failures. These two things we are studying in unit 4. And coming to unit 5, it is also having two parts. First one is the torsion of circular shafts, and second part is thin cylinders. So these two things we are studying in unit 5. So this is the syllabus of mechanics of solids subject. Okay. Next, we will have a look at the course outcomes of the subject. So that means at the end of this course, or you can say at the end of completion of the subject, students, what the student should be able to do. So they should be able to do these things. First one is they should be able to determine stresses, strains, elastic constants of solid bodies under various types of loads. And they should be able to construct a SFT and BMD in various loaded beams, and also obtain the relationship between shear force, bending moment, and rate of loading. Student should be able to derive the bending equation and also determine the flexural and shear stresses for various types of sections. Student should be able to explain the theories of failure and analyze the compatibility of various design parameters. And student should be able to solve problems related to torsion of shafts and thin cylinders. So these are the course outcomes of this mechanics of solids subject. So now in this presentation, we had an overview of the mechanics of solids subject. So that means what is the basic idea of mechanics of solids, why we have to study, and what is the syllabus of that subject, and what are the course outcomes of the subject. So I think what we have to, what ability we should have at the end of the completion of this course. So these things we have understood now. In the next videos, we will start our lectures on mechanics of solid subject, in particular unit wise. Okay, thank you.